So we did the ball toss activity, which we're going to finish when you guys come back on Monday. And so your homework is just to take notes on these two examples. So notice the first example talks about a parabola containing 3 points, and it asks for the equation of the parabola in standard form. So first of all, remember what standard form looks like. And you really have no other information except for the 3 points, so we're going to use them. And what I mean by use them is we're going to take each point and let it be an x and y value in the standard form of our equation and see what that looks like. So when I plug in 0, 0, I have an equation which simplifies on the right side. That's 0, and I just get that c is equal to 0. So I now know that the constant in my equation is 0. The next point I would plug in would be negative 1, 1. So I would plug in positive 1 for the y value and negative 1 for the x value. And if you want to at this point, you can also use that c is 0, because that will help make your equations a little bit smaller. So when we simplify this, we're going to get 1a minus 1b equals 1. Which we can't solve that equation for a or b on its alone on its own, but we do have a third point. So then we're going to look at the point 1, 5 and do the same thing. 5 is the y coordinate and 1 is the x coordinate. So, and again, I'm going to replace c with 0 to make my life a little bit easier. So we get 5 equals a plus b. So I know that c is 0. I'm looking for a and b, which neither equation on their own accommodates finding them. However, these two equations together can be solved as a system. So I'm going to take those two equations and look at them together, looking for the values of a and b. And lucky for me, they're already set up in a form where everything lines up nicely, and b is already to be canceled out when I combine these two lines together. So b cancels out, and I'm left with 2a equals 6, so a must be 3. And then if I plug that a value back into one of my equations to find b, I get that b is equal to 2. So now that I know my b value, my a value, and that my c value is 0, I know that the answer to this problem is that my equation is y equals a, which is 3x squared, plus b, which is 2x, plus c, which is 0. So I'll just leave the equation like this. And so I'm done with that equation. So you want to use systems to help you get through these equations. The next example we're going to look at is some data entry. And we're going to use our calculator to help us. So you see the data table here, and it has temperatures based on time. And what we're going to do is we are going to go ahead and predict based on a model that we're going to use. So we're going to use our calculator to build the model for us. Now, we can create the scatter plot in the calculator also, which I'm going to show you in a minute. The weird thing is we kind of really can't indicate on the graph AM or PM. So what we might do instead is think about like the 24-hour clock and how once it hits 12 noon, so those are the hours, 1 a.m., 2 a.m., 3 a.m., etc. And then instead of 1 o'clock, it's like 1,300 hours, 1,400 hours. So I'm going to go ahead and convert these to those hours. So like 8 a.m. would still be 8, and 11 a.m. would still be 11. 12 would be at 12 p.m. So kind of you're thinking about 12 a.m. as being 0, kind of our starting point. And so again, 8 a.m. would still be 8, 11 a.m. would still be 11. But 2 p.m. would be after 12 noon. So 12 p.m. is like 12. So 2 p.m. would be 2 hours after that, so that would be like 1,400 hours. So we're going to call that 14. And then we're going to call 5, 17. And we're going to call 8, 20. And we're going to call 11 p.m. 23. So you can see, you can think about it like military time or the 24-hour clock, or you can think about it as hours after 12 a.m., and it would be kind of the same idea. So when we enter into the calculator, those are the values that we're going to enter in. Okay, so we're going to use the calculator to go through the data entry. So on your calculator, you want to go to Stat, and you want to choose Edit. If you have anything already in your list, you want to clear them. Don't push Delete at the top of the list. Okay? Go up to the top of the list, so you're on the L1 or you're on the L2, press Clear and press Enter, and all the values in the list will go away. So I'm going to do that for both of my lists. Oops. Didn't work for L2. So clear it out. And then in L1, I'm going to put the time data, and again, we're using that 24 hours. So 8, 11, 14, 17, 20, and 23. And then in L2, I'm going to put the temperatures that were listed there. So 52, 59, 63, a couple of times, 58, and 56. All right, so once I've entered all the data, I want to see it on the plot. So again, go to y equals. If there's any equations in your y equals here, you want to clear them out if you only want to see the data. And then to get the data plot turned on, go to second y equals, which takes you to stat plot. Choose one of the plots by pressing enter. Turn it on by pressing enter, and make sure you've chosen scatter plot, that you have the appropriate lists, which for me was L1 and L2, and however you want it marked on the graph. Now remember, the calculator will zoom to your data if you press zoom and you press choice 9, which is zoom stat. Okay. So there's the data that we can see based on the temperatures that they gave us. Then if we look back at the question, our goal was to develop a quadratic model for this data. Our calculator can do that for us. This time we're going to go to stat, and we're going to arrow over to the right for calculate. And notice, because it's shaped more like a parabola, we don't want to do a linear regression. We want to do a quadratic regression. So we're going to choose choice 5 that says quad reg, which is a quadratic regression. Then you want to tell it which lists you're using. So in my case, list 1, comma, list 2, and we can press enter. So if you see here, you can see the A, the B, and the C value, and those would be the values of your equation in standard form. So we want to go ahead and we want to write these values on your note guide. Okay, so if we go back to our note guide and write in this information, it asks for the quadratic model rounded to hundredths for numerical values. So we're going to have y equals negative 0.16x squared plus 5.14x. And that c value, when we round it, the 9 gets rounded to 10, which essentially just makes it look like 21.60. So that would be the model for my quadratic. Now, the next thing it asks me is to use my model to predict the high temperature for the day. At what time does the predicted temperature occur? So I'm going to go back and look at the calculator for a minute just to understand what this is saying. And go ahead and go to your y equals menu and type the equation that we came up with in that menu. So we have negative 0.16x squared. We have 5.14x and 21.6. And now graph that with your data just by hitting graph. And you can see the quadratic on the graph. Now, notice that right here is our vertex, which happens to be a maximum point. And again, the question that they asked us was to predict the high temperature for the day. And then they asked us at what time would the prediction occur. So remember, our y values were the temperature. So the highest temperature it reaches is right there at the vertex of the parabola. So if I could know the vertex, I could know that temperature. So remember how we get the vertex of the parabola is we can go second, calculate, which is the trace button. And because we're calculating a vertex, it's either a minimum or a maximum, and in this case it's a maximum. So you press enter on maximum. It gives you a blinking cursor. You don't put the cursor right on the maximum. You pay attention to the directions. It's asking me for the left bound. So if this is where I think my maximum is, I want to make sure I'm a couple arrows over to the left and press enter, and I'm just saying that's the left boundary of where the maximum is. Then it asks for the right bound, so I'm going to scroll to the right and make sure I'm clear of where I think the maximum is, and press enter for my right bound and press enter for the calculator to guess. And so notice the maximum is at 16.06, comma 62.88. So going back to the question that they posed, use your model to predict the high temperature for the day. We were looking at a parabola, and that parabola has a vertex at 16.06, 62.88. So the high temperature, the y values were the temperature, so I would expect the high temperature to be that 62.88. And they gave all of theirs in whole number degrees, so depending on how accurate you want it to be, or 62.9 degrees. That's what I would expect the high temperature to be. The next thing it asked was at what time does the predicted high temperature occur? So for us, the time is this 16.06, or very close to 16 hours after midnight. Remember, that's how that represented. So 16 hours after midnight would be at 4 p.m. So we would expect our high temperature to occur at 4 p.m. So that's how we would use the data and the quadratic regression to infer. And again, we would run the quadratic regression in this case because the data didn't look linear. It didn't look like a line would describe what was happening to our data. It looked very much like a quadratic. But we can use it the same way that we used that linear data before. So you guys should have these two examples down when you come to class on Monday. We'll answer questions from homework 4. We'll answer questions you have about this, and we'll finish interpreting our data from our ball toss activity. Okay, I will see you guys on Monday.